Right, back to working on the little Lorch lathe. This is the headstock end. So we're looking at the back of the lathe. It's a well, it's in a bit of a state, but it needs a good scrape. The job for the moment is making supports for the lead screw to come out here and on the other end. You'll notice the way that this setup is. There are two 4mm dowel pins and two 6mm holes. Those locate the supports. On this end there's an arm that comes out, it has a piece that comes out from there, and then the threading banjo goes onto here. The other end's a bit more simple. Of course the hole patterns are not the same, so we can't make two identical pieces. The way that we're going to do this, because I can't pull these pins without massacring them, and they're in the way, we're going to need to punch some holes in a piece of paper to then pick up the rest of the surface in a similar way to making a gasket for the top end of an engine or such like. We do need a reference surface. We can't use the back end of the casting here. Back end of the casting is not exactly precision. We could possibly use this as a reference surface. It does appear to have been milled, although I would be cagey about using it as any kind of real datum. This surface here on the top of the slideways is obviously a datum, although it's slightly worn at the other end. It's not going to be too much of a problem. This face you can't use because that doesn't exist on the other end, but this face here is what things are located against. Well, not the saddle and cross slide obviously, but the headstock, for example, and the tailstock are both located on this face here. And the way that happens is you have a little square, basically a key that sits there, and then this or something similar to it, which works on this slope here, this dovetail here, is pulled up to clamp it into place. It's quite a neat little system. Looks relatively simple to recreate. So my datum point obviously is going to be this corner here. Now that's a problem. On the other end it's easy because the face on the other end is flush with the end of the bed, but here we're not. We have an offset. We have an offset of offset of how many? We have an offset of 5mm. So what we're going to do is first off I'm going to measure the distance between these two pins best as I can, and once I've measured that distance we will punch some paper at that distance, and then we'll use it to pick up all of the various reference points. The other end is the same, although I don't think the spacing between these two is going to be the same. That's around 40mm, and this one's around 33. No, okay. So I'm going to need to do this twice. So first thing is to get a reasonable pickup of the distance between those pins. You can't expect this measurement to be anything particularly coherent because obviously these will be positioned relative to some datum point when they made the casting. Actually, I might try that with a micrometer. I should have it lying around here somewhere. Not there, obviously. Where is my 25 to 50? I know it's around here somewhere. And there it is. It was in the micrometer box, surprisingly enough. So let's come out to 40 and something. 40 and odd. And we'll try and get a reading on that. Get the anvils relatively close. What's the shortest distance? the distance where I can't go any shorter? Actually, no, I don't, do I? I want to definitely be there. And that says 40.22. So 40.2, I think. Right, markup time. Now we have a piece of paper. I reckon that the distance between the outside of these two pins is 40.2 millimeters. Now 40.2 less the 4 millimeters of the diameter of the pins is 36.2. I've marked a point on my piece of paper. I'm going to mark another point on my piece of paper at 36.2. So we use the, it's the sharpest end, isn't it? Just there. I'm going to centre that one on there, and we're going to put that about there-ish. That should be the hole spacing for those two pins. So what we do now is we take our little bunch of what we have made from a piece of shitty old supermarket 6mm bolt, and we punch. And then we do the same here. Here. And we have two holes. And those two holes should go over two pins. 7 brides for 7 brothers. Yes, how about that? Now then, there's a few things that we're going to need from here. First of all, we need our datum point. Well, we're going to leaving those on there and being careful not to mess things up too much. They're kind of grubby hands for this job, but there you go. So we're going to mark our datum point. That's the datum. We also need to mark a horizontal reference. Well, for that we can use the top of that milling in the bed, or we can just mark the top of the bed. And the bigger we mark this, the better, because it means that we can more accurately line shit up. The next thing that we need is the holes. So, keeping stuff relatively in place, we're going to mark our holes with our fingers, like that, and should be one up there somewhere, like so. I'm sorry if this isn't very clear. It's not very clear, is it really? Especially if I bring that round there. Autofocus, yes, we're there, and we go to manual focus. And then we can go for some tappy 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 tap to cut our holes. We don't actually need to cut them really, but they're really relatively well marked. And then the last thing is with a piece of 12mm rod clamped in the lead screw nuts, we bring the carriage forwards, clamped in the lead screw nuts, I said. We bring that forward and we mark where the lead screw is. And we have a piece of relative positioning of our holes. And I'm going to stop now because I'm running out of battery, and we'll come back when we're at the computer. Right, well, I'm no OBS whiz, and I'm certainly no Freecad whiz, but here we are in Freecad. And what we're going to do is we're going to go import. Is that showing there? Oh, it is good. Okay, right, yeah, and there's my headstock end. Bing! So that's just been scanned in. I've not done anything to it. The scanner brings stuff in at 100%. It lets me rotate stuff when I'm scanning, which is quite neat. So I'm relatively close to being square, I think. What we do now is we create a new body, and in that body we create a sketch, and we add sketch to the XY plane because that's where we're attached. So yes, select the XY plane, that would be a good idea, wouldn't it? And what we can then do is, while that sketch is open, we go back to model and we go to the data of the scan, and we can we can position it. Now we look to be relatively close on X. Maybe we want to go about -1 millimeter. That brings us more or less into line. And then on Y we want to go minus or positive plus, probably. No, -20. Let's look at that. Yeah, there we go. -23. Oh, bing bong. How about that? Now you will notice that we're not absolutely square. So what we want to do is we want to rotate by 0.5, a bit more, 0.8, 1.2. That's getting pretty fucking close, isn't it? 1.3 degrees, 1.4 degrees. Yeah, I'd say that's good enough. And then my X positioning wants to be a little bit more to the right, so I want to go to -0.5 probably. Yeah, okay, there we go. So we now have the origin set on our datum point on the bed. Now that's the front end of the bed, and what we can now do is we can chuck some circles in place. So we're still in the sketch. Let's add some skirkles. So skirkles, there we go. Bish, bosh, bish, bosh, bish, bosh, bish, bosh, bish, bosh. Now that's added a couple of constraints that we don't want. It's made those tangent to the axis. Don't want those. Go away. We can now go to constraints and we can constrain a diameter. So that one is going to be 4 millimeters. That one is going to be 4 millimeters. That one is going to be 6.2. Up. Clearance hole for a 6mm drill. That's 6.2. And that one, 12. And now what we can do is we can move stuff around a little bit to fit stuff as far as possible. So there we go. We'll fit you in the middle of the hole. And we'll fit you in the middle of the hole. And we can zoom in a bit to make sure that we're a bit closer. And we can fit you in the middle of that hole there. Now you'll notice that that hole is actually bigger than 6 millimeters. Why is that bigger than 6 millimeters? That's a good question. Has my scanner fucked up? We can see in a minute. And we can move you. You're 12 millimeters. No, you're 12 millimeters and you're bang on. So that's all good, yeah. Right. So let's come to here. Quick sanity check. Measure. Can we measure in here? No, we can't. Okay, well, let's just add a dimension constraint between these two pinholes. 36.4 millimeters. That looks about right. Let's make it 36. Bang on. It was 36.2, wasn't it? There we go. Maybe we might have been slightly off on our measurement. So yeah, 36.4 looks about right. That's good. Let's come. Oh bugger! So I told you I'm not very good at Freecad. Go back into the sketch, you sod. Oh come on, zoom. things a bit cleaner. So that it's readable. That must be there like that. That must be there like that. That must be like that. That must be like that. That one must be like that. Right, there we go. Dimensions for my part. Okay then, so here we have, boys and girls, a couple of roughed up end plates. They need a bit more work. I mean, this one needs quite a lot of material removing from it, needs the hole making slightly bigger. This one needs the hole making a lot bigger and rounding off, and then having an insert put into it for the banjo to sit on. But they fit, and they meet up with the extension of the extension of the lead screw that I've made by putting a 12mm thing in the whatchamacallit, in the carriage. So there you go. That's how I've gone about reverse engineering some stuff that I didn't have. Yeah, onwards and upwards. I'll catch you in a bit. Bye.